Good morning, friends. I am here again for my course, Aircraft Systems. Today is lecture number 14, and topic for today's cycle is air cycle systems. In that, we have the basic cycle, vapor cycle, bootstrap, evaporative vapor cycle. These all things I am going to discuss today. As you know that my name is Dr. Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. Till now, I have completed my first module. In that module, there were 4 major systems. The first one was airframe or structural system. Then second was vehicle system. Third one was avionics system. Fourth one was mission system. In aircraft structural or airframe system, I have covered the structural component like wing, fuselage, tailplane, empennage, and their constructions, how the wing is constructed with different longerons, stringers, and all. And for the fuselage, this is we have seen that this monocoque, semi-monocoque, and different types of this thing. And for the empennage also, we have seen that there is a horizontal tail, vertical tail, then a rudder, then we have this elevator, and there are so many other hydraulic and pneumatic equipments which are fitted to operate the elevator and the rudder and some other component. Also, there are few access windows from where we can access the maintenance and we can inspect the component of that area. So like this we have done in this airframe systems. We have seen that in our this vehicle system, it covers the flight control system, it covers the electrical system, hydraulic systems, and other things it is covered. This will be undertaken in due course of time. And in avionics system, we have seen that there are some communication system, navigation systems, and there is some flight management systems. These all things. And then in mission system, the mission system is basically related to the military aircraft. In that we have the search and rescue purpose. We have some passenger and cargo missions. We have some this like in COVID time we have done this mission to communicate this vaccine from India to abroad. And in India also different cities were done by the help of the aircrafts. If you see the military aircrafts, we have the fighter aircrafts. They do the this striker, and they are the bombers. And for the naval aircraft, if you can see, they are anti-submarine warfare, for the long-range reconnaissance and all. These are the mission, and at that mission, what type of equipments, what type of sensors, and what type of other accessories are required, that we have given a glance in this previous my classes. In this module 2, I am here, and in module 2 also I have covered some 4 classes or 5 classes already. And in that we have first one, I have covered the electrical system. And if you see in the electrical system, we have seen that how the AC generator, DC generator, and then how power is distributed and how this is converted from AC to DC. We have also seen that how the frequency of AC power is very important, and we use 400 hertz in and above. So it is a fixed frequency, constant frequency, but sometimes we need the variable frequency also. So this variable frequency can go up to 360 hertz to 780 hertz. In between, we can generate and we can distribute for different types of systems which are used for AC systems. You know that the aircraft is having a lot of equipments with different types of power rating. Few are operating with the AC, few are operating by the DC. Even the AC also, they are few equipments are operating in the different voltage and different frequency, and another system is operating in different DC voltage also. So we have mostly covered these all things, and now today I am going to start this air cycle, means refrigeration and air conditioning. It is related to the refrigeration and air conditioning of the system, and why it is so much necessary. That also we have to see. In today's class, I am going to discuss about air conditioning and pressurization system of the aircraft. And this air conditioning and pressurization, we can see that basic air cycle, then vapor cycle, then bootstrap cycle, then we can go to evaporative air cycle systems, and this I will be discussing in this today's class. So here, why we need first I want to discuss why we need the air conditioning and why we need the pressurization. You know that the human being is born in the earth, and human is very much habitual to stay in earth, and the earth atmospheric pressure and earth temperature, which is ranging nearly from 10 to 40 degrees centigrades, are very common, and in this temperature human don't feel very discomfort. Also, the pressure of the atmosphere is very suitable, and the pressure of 1 bar, which is atmospheric pressure, the human can be very comfortable in this zone of pressure. But we know that the atmosphere is not like that. Just I will draw one diagram of atmosphere and how this atmosphere is varying with height. So this is the temperature in Kelvin, and this is the altitude. Altitude. If you see here, this is the density here. I will put here density. Or this, I can put here the pressure. So I am drawing here approximately, this is the 288 Kelvin, and here approximately this is the 11 kilometer. So up to 11 kilometer it is like this, then it is goes to like this, then it is goes to like this, like this. This is the atypical. This is the 100 kilometer here. So up to 11 kilometer, if you see, I am just, this is called the troposphere. Here is mesosphere. Up to here, this is the mesosphere. Then thermosphere. Stratosphere. Then we have the mesosphere, and then here we have the thermosphere, and this is somewhere in 100 kilometer. So it is just a rough I have drawn. It is not the exactly, but I want to explain that how here, if it is here 100 or 1000, it goes to 100, then it goes to 1. The pressure is reducing. Okay, so as this pressure reducing, and temperature, as you see, as the height is increasing up to 11 kilometer, that temperature is also decreasing. Decrease in temperature, you can see here, temperature decreasing up to 11 kilometer. It is called the tropopause. Up to tropopause. Oh, this line is here. This is the tropopause. So I will just take only up to this 11 kilometer. If you see here, up to 11 kilometer, your pressure is in hectopascal. So from 288 degree Kelvin, as you go about up to 11 kilometer, temperature has reduced here, and it is somewhere, it is very less temperature, minus 10 degree here. 10 degree Kelvin, no, it is somewhere 200 something, 263 something degree Kelvin here. Okay, so in this, temperature is reduced here, very cool here, But human or your equipment also, they are not habitual to stay in this type of environment, and we need some knowledge then how our equipments and how the human being and the how pilot will survive this type of less pressure, less temperature and less density environment. Also, we should know that the lift is directly proportional to the density of the atmosphere. As you go higher and higher, the density of the atmosphere is reducing, and same way the lift of the aircraft and the thrust producing capacity of the engine is also reducing. So we as engineer and the pilot, we should understand that what is going to happen if this is like this. So that is the objective of understanding air conditioning and the pressurization, because our ears, our eyes are balanced by some certain amount of pressure, and if the pressure is going above or below that pressure, we will feel very discomfortable. Even sometimes our ear may pain, and if you go very, very high, lower or higher pressure zone, our membrane of the ear may burst, and eye will also having the effect. Your brain, your blood, these vessels will also get fractured, and there may be a lot of issue in your brain, and so many other problems are going to face. So we should understand that how we can generate air conditioning and how we can generate the pressurization of the aircraft. So that is the objective of this class. Here I am going to discuss about the simple basic aircraft refrigeration cycle. So here I have shown a very simple thing. If you see here, ambient air is here. Air is passing from this side. It is entering in the channel. This is called the ram air. Some part of the ram air is entered in this first one. It is called heat exchanger. Then it goes to the main compressor. This compressor is a part of engine. From here, air is compressed. Then it goes taken from here, and then it is coming again to the heat exchanger. Then some part of this compressed air is going to the combustion chamber. Here fuel is burnt. Here fuel is burnt, and this high temperature and high pressure gases are entering in the turbine, and the thrust of the engine is produced by the help of this turbine. Okay, so some part of this main compressor, the pressurized air from the main compressor is tapped. It is called the bleed air. This is called bleed air. Bleed air is tapped from here, and some part of the air, it is cool air only, but here somewhat heat air. Due to pressurization, it is hot, and this hot air and pressure with the pressure is coming here, going to this heat exchanger. This heat exchanger, the high pressure air is some part of heat is absorbed in this, and this high pressure air is entering in the cooling turbine. Cooling turbine is rotated by the help of this, and the further it is cooled, and this air is going to the cabin, and where our electronic equipments and our fuselage and where passengers, cargo, your pilots and air crews are present. And this is also rotating a fan. This fan will make to exhaust. This will make that this air is moving very smoothly and going away. So this purpose of this cooling air fan is to throw back this air to the atmosphere. So that is the objective of this simple basic aircraft refrigeration system. You can see here that in this diagram 1, 2, here we have 2 dash, then we have 2 to 3, here we have the 3 prime or 3 dash, then from here we have the 4, from 4 we have to 5 and 5 dash. So all this dot, they are the theoretical one. Like here 1 to 2 dot, 2 to 3 dot, 4 to 5 dot, they all are the theoretical. And the actual cycle is 1, 2, 3, 4 and 5. The firm line is the actual cycle, a theoretical cycle. This actual in the real of what will happen. Okay, so here TS diagram is shown. So I will start with first 1, 2. 1, 2 is a ram compression. This you can see here. Here is the ram. This is some pressure is increased by this 1, 2. 1, 2 dot is a 1, 2 prime is a theoretical. It is a adiabatic process. But in the real sense, it will not be adiabatic, but it will go like this. Okay. So this is the practical or actual cycle. From 2 to 3, it is the main compression. So here this is the 1 to 2 and here this is the 2 to 3. Okay. So we can compare this two diagram. So 1 to 2 is a ram air compressor. It is the ramming action of the air which is entering inside the aircraft. 2 to 3 is the main engine compressor. This engine is pressurizing this air. From here, air is tapped. 3 to 4, it is a heat exchanger. This is the 3 and this is the 4. 3 to 4, it is a heat exchanger where heat is exchanged and the temperature is falling from 3 to 4. This air which is coming from this compressor is somewhat cooled and then it is entering to 4 to 5. 4 to 5 is a cooling turbine. This 4 to 5 is used to cool the further cooling and from here this goes to the aircraft cooling purpose. Okay, so it is very good system which I have shown you here and hope this is quite simple. So here 1, 2 is a ram pressure. This is happening due to the ramming effect of the inlet. Some part of this ram air is taken out. This is still cool. This cool air is entering into the heat exchanger. There the main compressor is compressing the air which is entering from few stages back of the main compressor. We are taking the high pressure and somewhat higher temperature air is taken and then it is entering inside the heat exchanger. Inside the heat exchanger, the air which is coming from the ram air is cooler than this compressor air. So some cooling is taking place in the heat exchanger and from here this air is coming and this air is entering to the fan. This fan is used to, it is rotating by the help of the turbine, which turbine is generated the work because it is expansion is taking place in the turbine and we are getting the cooling effect and the energy or the work which is generated by the turbine is transferred to the fan and the fan is rotating and in this way this is working as an exhaust fan and your air is exhausted. So this is a simple basic aircraft air cycle refrigeration cycle. Now I will talk about the bootstrap air conditioning system. So what is the bootstrap and why the name bootstrap is coming? Bootstrap air conditioning system utilizes high speed air to reject excess heat energy from the airplane cabin. Air is used as a working fluid in it. The air is compressed in 3 stages intermittently while passing through 2 heat exchangers. So you might have seen that in the previous one only 1 heat exchanger is there, but here we have the 2 heat exchangers. So that is called the bootstrap, means further enhancing its capability. So it is suitable for application where air speed is very high, that is in aviation or in aircraft industry. Bootstrap refrigeration system is not compatible with low speed transportation, means the flow rate of the air must be very high to extract the heat energy. If the airflow speed is not high enough, then bootstrap cooling is not effective. So that is one takeaway of this thing. This system can be used only for a high speed flight, high speed vehicle like aircraft. It is not suitable for a ground vehicle. Okay, so that is the first. So now bootstrap air conditioning system. Here also like the previous one, but here we have one additional. This you can see in the previous one only one heat exchanger was there, but now we have here two heat exchanger. That is the one and that is the two. So here we have the second heat exchanger. That is the first thing difference. And here is also we have the secondary turbine, and here we have the secondary compressor, and then we have the cooling turbine, and from here this goes to the aircraft cabin, fuselage compartment. Okay, so these things are supplied in this way. Here also, if you see here, ambient air, which is here is the ram air which is entering from here. This ram, some part of this ram air is taken here. This air is still cooler than the air which is supplied by the main compressor. This air from the ram, it is entering to the main compressor. In the last few stages, some part of the air is trapped inside and some part is going for the combustion here. Here the ignition is taking place, fuel is injected, here fuel is injected, and from here the high pressure and high temperature is entering to the gas turbine, and this gas turbine is rotating the main compressor, and further this thing is going for giving for the thrust by the propeller or by the jet by the help of the nozzle. So we are not concerned with this side, but we are very much concerned from here, how this side is working. In the basic one, we have seen that there was only one heat exchanger, that is the one, but here we have the two heat exchanger, that is why it is called the boot strap. One more step is given. And if you see here, the ram air, which is already cooled, it is entering here, it is going to both of this heat exchanger, and the high pressure air, which is called the bleed air. Here it is called the bleed air. Bleed air. Bleed air is taken, and this bleed air is entering from here to the first heat exchanger. Then it is cooled here, and this air is exited. From here, cooled air is again entering to the next compressor, so that it is pressurized. We need a high pressure but less temperature. So one more compressor. So here 3 stages pressurization is done. In that it was not there. This pressurization was also not there. So this whole system was not there. And from here it goes to again to the heat exchanger. And from this heat exchanger 2, which is also cooled by the help of the ram air, and it is entering to the cooling turbine. And this cooling turbine is rotated, and here due to expansion of the gases, expansion of the air, temperature is further reduced. Temperature is further reduced. So in this way, we can get the high low temperature by the help of the turbine, and the work which is produced by this turbine is used to rotate this compressor. Okay, so we don't need any power for this, and the power which is generated by this is used to rotate this compressor. In the previous one, if you see what is the difference here, we have a fan. This fan is used to make as an exhaust, but here in a bootstrap method, this is used to operate another compressor, so that a further effectiveness and further increase of the reduction in the temperature can be achieved by the high pressure entering in the turbine, cooling turbine. So that is the objective of this bootstrap AC system. We can see here the TS diagram of the bootstrap AC system, and we can see here that 1 to 2 is a ram compression. This you can see 1 to 2 is a ram compression, 2 to 3 is a main compression, 2 to 3 is a main compression, 3 to 4 is a cooling in first heat exchanger. This is the first heat exchanger. So in this heat exchanger, cooling is taking place here in this. Then 4 to 5 is second compression here. This is the 4 to 5, 4 to 5. This is the 3 to 4, 4 to 5. Here 5 to 6. Here 5, and this is the 6. And now this is the 6 to 7. So that is the, just I will show you again here how numbers it is. This you can see here that RAM compression. This is the 1. This is the 2. This is the 3. This is the 4. This is the 5. This is the 6. And this is the 7. Okay, I have given the number. So you can very much easily detect what is the meaning here. 1 to 2, this one is a RAM compression. 2 to 3 is a main compression here. 2 to 3, it is in the main engine compression. A high compression is taking place. That is the 2 to 3. 3 to 4 is a cooling in a first HE. Okay, then again the temperature is increased in the second compressor. It is 4 to 5 in the second compression. Compression is taking place, and again cooling is taking place 5 to 6 in the HE2, and then 6 to 7 is the final temperature, which is obtained by help of this system. So this is the bootstrap air conditioning system, and this system is very effective for a high speed aircraft where the flow of air is sufficient, the velocity of air is sufficient, is available, and the amount of air is sufficiently available, where this can be used very nicely. So what is the merits and the demerits of this bootstrap system? Convenient and abundantly available refrigerant, that is air is available in aircraft. Harmless refrigerant, we don't use any chemicals. Low weight per ton of refrigeration, the weight of the system is very much less, so that it is very useful for aviation purpose. No evaporator space cost required for that. Simple design due to low pressure. Here pressure is not, we are not increasing very high pressure. So the components we use is very small size, and the weight of the components are very less. No refrigerant phase is required, and cabin pressurization is done with help of this. And what is the disadvantage or demerits? Lower COP. The COP of this system is, or efficiency of the system is low. Frosting due to high moisture content in atmosphere. You may get some moisture. This moisture may be used. It may be freeze inside the pipes, and the blockage may take place. So that is also one disadvantage, and dust and pollution of air will also enter in this type of system. So these are the demerits, but if you can see, merits are very more. So in aircraft we normally use such type of air conditioning system. Now if you see here further, it is explained here how air conditioning system is working. So this you can see here that, so here this you can see that some part of the air is coming here, and here is from the compressor, it is coming here. There is a control valve, then it goes to the primary heat exchanger, from where this fan air, this you can see, this is the ram air. This is the ram air. Ram air is entering, and this is going to the primary heat exchanger, from where here some pressurized air is also coming. From there it goes to the here air cycle machine. Here is the air cycle machine, compressor, pressure and temperature, and from here it is main heat exchanger. It goes to the another heat exchanger, and this heat exchanger is supplied. Here is the ram air, this ram air is entering here. Okay, so now here is a turbine, and here is the compressor. So in compressor, the pressure and temperature is increased. In turbine, what happened? Pressure and temperature is decreased. So this decreased pressure and temperature is entering with a water separator. I told you that there is a problem in the bootstrap method that we don't have any water separator, so it may freeze. And where these things are supplied, just this is the aircraft. Okay, this is the aircraft, and in this aircraft, here, all the places the air conditioning is supplied. So it is a very simple sketch of the aircraft air conditioning system, and hope this is the principle is same. Only here depiction of the engine from where it is taken. In the previous diagram, if you see, I did not show any engine here. Okay, but in this diagram you can see that there is a engine, and from this engine, from where it is trapped, it is the inlet. This is the inlet, and this is the ram air. This ram air is going to the fan, and some amount is pressurized, and then it is entering here, and in this way it is going like this. And the high pressure and high temperature after compressor, main compressor, it is entering in the heat exchanger. So this high temperature and high pressure, it is cooled by this air which is coming from the ram, and some cooled air is entering in the another compressor. There further this temperature and pressure is increased, and this increase in temperature and pressure again goes to the ram air cooling, and from there it goes to the turbine. In turbine, expansion taking place, and from here it goes to in this direction, and further we have the water separator, and we can also put the filters so that any pollutants can be also removed. So what is the refrigeration? I want to give a definition of this. The removal of heat from one place, that is water, and depositing it to the another, that is air, water, using an intermediate medium, that is vapor compression refrigeration system. This transfer of heat from one place to another is done through the evaporation and condensing of the refrigerant. So this is the definition of the refrigeration. So the removal of heat. So in this we have to remove the heat from, and we have to transfer to the higher source. So we need some power to be by the second law of thermodynamics. So here if you see basic refrigeration cycle, so here we have the compression. So first we have to compress it, then it will go to the condenser. There you can see it is compressed, and then here it is a condensed. This condensed will go to the expansion. Here the gases will expand, and this expanded gases will enter to the evaporator, where the cooling effect will take place due to the evaporation, and then again it will circulate. So these four components are very much essential for any basic refrigeration cycle, that is the compressor, then condenser, expansion, evaporation, and the compressor. So these parts are very much essential for any refrigeration cycle. So refrigeration rules of thumb. Heat transfer always occurs from a region of high energy to another region of low energy. So always heat will go from high temperature to low temperature only, or high energy region to the low energy region. The greater the temperature difference, the faster energy will flow, attempting to reach equilibrium. So if you have the high temperature, as much you have high temperature and this is the low temperature, so it will go very fast. As the difference between the temperature is very high, the flow of energy will be very high. Temperature indicates the velocity of molecules of a substance. As heat energy in a substance increases, its molecule vibrate faster. So if the temperature is high, the molecules will vibrate very fast, and they will this you can see here, this red is a very high energy and the blue is low energy. So from high to low it is possible, but from low to high it is not possible without giving some additional work. So here also it is shown here from small to low, low to small, high is not possible, and we need to do some additional work. Pressure drops when volume increases. So if you increase the volume, pressure will drop. So P and V, pressure and velocity, they are the inversely proportional. We know by this Boyle's law. I think this is same. So here vapor compression system components, we have what are the components which are used for the vapor compression cycle. However, we use in aircraft, we use the air compression, air cycles only. So we need here a compressor, a condenser, a dryer, expansion devices. We have the thermal expansion valve, that is called TXV, and the capillary tubes. Then we have the evaporator and hot gas valve. So these are the compressor, condenser, dryer, expansion valve. Expansion valve, we have two types. That is the thermal expansion valve, that is called TXV. Another is the capillary tube. Another is evaporator and hot gas valve. So here I am showing you the vapor compression cycle, and these components are shown here. And this you can see here that I will start with the compression. So start that air is entering here in the compressor, and in this compressor P and T increases, here temperature and pressure increases, then it goes to the condenser. Here what happened? It is condensed air or the liquid which is compressed, it is now condensed here. Then it goes to a thermal expansion valve where expansion is taking place, and this going to the evaporator. In evaporator some pipes are there, and this here evaporation will take place and heat energy will be extracted here, and cooling will take place. Cooling will take place. Here we have some hot gas valve. So these hot gases we can transfer from here to here or here to here as per the requirement of the system. Now I will discuss about the compressor. The first major component of any air conditioner system is the compressor. It performs two primary functions. First one, pulls low pressure vapor from the evaporator. If you see here, this is the evaporator, I am writing E, and this is the compressor. So from here, low pressure, it is sucking from here to low pressure to high pressure. Compressor compresses this vapor into a high temperature and high pressure. So here P and T increases. This is the purpose of this. So first purpose is to pull low pressure vapor from the evaporator. Second one, it is to increase the pressure and temperature of the vapor which was sucked from the evaporator. So these are the two primary functions of this compressor. Now these are the condensers, water cooled, and here is the air cooled condenser. It is like a pipe. Here this you can see it is like a heat exchanger. You might have seen in our trucks and our car and all. So this is the water cooled condenser. So here we have the two types. So one is modine, it is called air cooled. This one is the modine, and this one is Packel. Okay, this is this and this is this. Okay, so here we have water cooled, but in aircraft we use the only air cooled, but in our vehicles, our cars or your home, we use the water cooled condensers. Okay, so what is the purpose of this condenser? Condenser removes heat from the refrigerant by providing a medium at a lower temperature to which the heat may flow and be dissipated. So the main purpose of condenser is to remove heat from the refrigerant, because refrigerant is absorbing some heat by providing a medium at a lower temperature. So we have to provide a medium so that the this refrigerant which is having high temperature can be condensed, to which the heat may flow and be dissipated. Superheated gas is converted to a subcooled liquid. So if we superheated gas which is having very high temperature, and if we make it to convert to a liquid, automatically the temperature will come down. Two sources of this heats are the heat absorbed by the evaporator and heat added to the refrigerant during the compressor. So these two sources of heat which has to be taken by this condenser. So heat absorbed by the evaporator and heat added to the refrigerant during the compression. So these are the two purposes of this condenser. Now I will go for the third component, which is the expansion valve. So here thermal expansion valve, it is also demonstrated by TXV. TXV, an exception device, is an expansion device which throttles high pressure liquid to low pressure liquid. So the purpose of this thermal expansion valve to reduce the temperature, to reduce the pressure, high pressure to low pressure liquid. Expansion during this process meters refrigerant into the evaporator based on temperature measured at the evaporator outlet. So the purpose of this thing is to high pressure liquid to a low pressure liquid, it is transforming. Expansion is taking place. Due to this expansion, the temperature is also falling down. And the location is of this TXV is between evaporator and the condenser. This is the compressor. Okay, so your thermal expansion valve is located between evaporator and the condenser. And the purpose of this thing is to throttles high pressure liquid to a low pressure liquid. So that is the purpose of this. Now TXV further in detail it is shown here in this diagram. First I will just explain here. The thermal expansion valve has only one function. It meters the flow of liquid refrigerant into the evaporator. It meters the flow of liquid refrigerant into the evaporator in exact proportion to the evaporation rate of the refrigerant in the evaporator. So it will meter how much quantity is required and how much evaporator can evaporate. That much amount of refrigerant it will be sending to the evaporator. By responding to the temperature of the refrigerant gas leaving the evaporator and the pressure of the evaporator, the TXV can control the gas leaving the evaporator at a predetermined superheat. Okay, so if you see here, we have here expansion valve here. This you can see here. We have here filter. We have the inlet port. We have the superheat adjuster here. Here we can adjust how much is required. Here is the outlet port, superheat spring, superheat adjuster, filter, and here is the sensing bulb. Here is the capillary tube, and in this inlet. So here it is entering from here and it is leaving from here. So this is outlet. And from here it goes to the expansion valve. Okay, so like this is the basic structure of the thermal expansion valve. Now, further this you can see here that here we have two zone. One is the high pressure zone. This side is high pressure zone and this side is low pressure LP zone, and this is the high P zone. So up to compressor, from compressor to the condenser, and condenser to the thermal expansion valve. It is a high pressure, and this thermal expansion valve is reducing the pressure and it is sending a metered quantity of refrigerant at low pressure to the evaporator, and in this evaporator it is expansion is taking place and cooling effect is taking place in this evaporator. So we can divide this refrigeration into a two part. One is the high pressure zone, another is the low pressure zone, as shown in this diagram. Next is the filter dryer. This you can see here, one filter is here, and also it is used to dry the air. Means moisture it has to remove. A diagram is shown here. It absorbs the moisture desiccant called molecular sieve, filter non-soluble contamination, debris, any type of non-contaminated particles in air also can be filtered, removes acid, activated alumina and other things. So this is the objective and this is the function of the filter dryer. So it absorbs the moisture, it also filters the non-soluble contaminations, also removes acids and any activated alumina and other part of the system. Now next I will talk about the next important part of the refrigeration system, that is evaporative, and this is the last part of this evaporation or the air conditioning system, which is the evaporator. The low pressure liquid from the expansion valve has a saturation temperature well below that of the surrounding medium. This results in a rapid boiling of the refrigerant with heat being absorbed from the surrounding, the desired cooling effect. So how it is happening? It is very good process, like our sweating. How we get sweat? After sweating, we get the cooling effect in our skin. Same way, evaporator is acting, and the low pressure liquid which is coming from the thermal expansion valve has a saturation temperature well below that of the surrounding medium. So its saturation temperature is well below the surrounding medium. This results in rapid boiling of the refrigerant. So it starts boiling itself and vapors have started coming with heat being absorbed from the surrounding. So the heat of the surrounding is start absorbing. So the cooling effect is taking place. So this you can see here how it is happening here. These are the boxes. In this the low pressure refrigerants are entering by help of the TXV. From there, due to its saturation temperature which is below that of the surrounding medium, so that the surrounding medium heat is absorbed and the surrounding it becomes cool and cool. In this way we get the evaporation on this. Another component is hot gas valve. This you can see here. The hot gas valve is this one. It is shown here. Hot gas valve which is opened during the harvest cycle, allowing hot gas to flow from compressor to evaporator. Hot gas warms the evaporator, which assists in releasing the ice slab from the evaporator surface. You might have seen in your refrigerator that if the ice is formed, very huge amount of ice is formed, we cannot take out the ice. So we have to push a valve. That valve, you have to press it. So the hot gases which are coming from the compressor will not go directly to the condenser and this thing. They will go directly to the evaporator, and evaporator will get heated and your ice will start melting. So this can be used for the cleaning and for the defrosting of the air conditioning system. So that is the purpose of hot gas valve. So here I have taken some references. These references are from the Moyer. So Moyer I and the Seabridge, aircraft systems, mechanical, electrical and avionics system, Professional Engineering Publishing Limited, London, and Bury St. Edmunds, UK. And another book from the same author, Moyer and the Seabridge, a design and development of aircraft systems and introduction, AIAA education series. In next class, I am going to discuss about further of the aircraft systems related to the icing, de-icing, oxygen systems, oil systems and other things I will be handling. Hope this class you might have liked, and if any questions you are welcome to ask to me the questions, and I will be very happy to answer your any query, any problem. My email for this is ydwivedi@gmail.com. Please do like and subscribe this channel, and further we can interact in this email. Thank you very much for joining this class. Be tuned for my next class. The next class will be quite useful and quite interesting. Do join, do subscribe this channel. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.